Kc and Kp, equilibrium constant in molar concentration and equilibrium constant in partial pressure. We have learned Kc and Kp in detail in the previous lesson. In this lesson, we are going to learn relation between Kc and Kp. So, let us enter into the matter. Relation between Kc and Kp. Let us consider a general reversible reaction. A general reversible reaction. Here, lowercase a, b, l, m are coefficients of uppercase A, B, L and M respectively. Let us consider equilibrium constant in molar concentration. Kc is equal to, we can write according to law of mass action, concentration of L, lowercase l, into concentration of M, here M, into this, divided by concentration of A into concentration of B into this. This is equation for Kc, equilibrium constant in molar concentration. Suppose this is equation number 1. Then, when all the components are in gaseous state, then we can write Kp, equilibrium constant in partial pressure. According to law of mass action, we can write partial pressure of L. Here, lowercase l will be as power into partial pressure of M, here M, and so on, divided by partial pressure of A into partial pressure of B, and so on. This is the equation for equilibrium constant in partial pressure according to law of mass action. Suppose this is equation number 2. Now, what is P? What we can write for P? Suppose this is a mixture of ideal gas mixture. In which n mole of a gas whose partial pressure is suppose P, and the gas occupies a volume V at a temperature T. In this mixture, a gas of n moles whose partial pressure is P, and when the gas occupies a volume V at the temperature T, then we can write PV is equal to N T. Then P is equal to N by V T. Then P is equal to N by V, that is number of moles per unit volume, which is a concentration. Here we got P is equal to CRT. Now, putting the value of P in equation 2, we got P is equal to CRT. Here C is concentration. Now, putting the value of P in equation number 2, we get Kp is equal to P C R T. Here C is concentration of L. So here L, overall power is L into C R T. This is M, overall power M into so on, divided by C R T. Here concentration of A, overall power A into C R T. This is concentration of B, overall power B, and so on. This is the equation we got, putting the value of P in equation number 2. From this equation we can write Kp is equal to concentration of L into concentration of M into so on, then into RT. Now L plus M plus and so on. Here powers are added, divided by concentration of A into concentration of B into so on, into RT, then A plus B plus and so on. This is the equation we got from equation 2, putting the value of P. Now we can write, from this equation we can write Kp is equal to, here for this we can write Kc. We know Kc is equal to concentration of L into concentration of M divided by concentration of A into concentration of B. Here concentration of L into concentration of M divided by concentration of A into concentration of B. So we can write Kp is equal to Kc into this, that is RT. Here this power minus this power, L plus M plus and so on, minus A plus B plus and so on. This is we got from this equation. Then we can write Kp is equal to Kc into RT. This equal to, we can write delta N. Here delta N is equal to difference between number of moles of products and reactants, that is number of moles of products minus number of moles of reactants, number of moles of products minus number of moles of reactants. This is delta N, difference of number of moles of products and reactants. Now delta N is equal to, you can write number of moles of products minus number of moles of reactants. When we are considering forward reaction, these are reactants, these are products. Now we got Kp is equal to Kc RT delta N as power. This is the relation between Kp and Kc when the reaction is suppose this reversible reaction, here hydrogen iodide, in this case 2 moles, in this case 2 moles. For these types of reactions we can write Kp is equal to Kc, RT, difference of products and reactants is 0. That is, here delta N is equal to 0. Then we get Kp is equal to Kc, because RT when power is 0, then this equal to 1. So in these cases we got, this is the relation, Kp is equal to Kc. This is all about relation between Kp and Kc. Today, thank you very much.